Hi, so welcome to our group project for project three. I am Noah,
I'm Joel.
I'm Parsh.
and so the three of us have put together EZPark, an application where users can put in a latitude and longitude to find nearby locations of other parking violations. So the primary data structure that we're using for this project is a graph, more specifically K&N graph, and then Joel's going to talk a little bit about the algorithms that we use.
Yeah, so the two algorithms we use are BFS and Dijkstra's. And so for BFS, the edges will represent simple connections between locations. And for Dijkstra's algorithms, edges will be weighted based on the geographical distances between locations. BFS will help us explore all like the reachable violation locations, and then Dijkstra's will help find the shortest path from the user's location to like different violation hotspots, letting us compare like the efficiency and effectiveness of both algorithms in predicting parking violations.
All right, so Joel, Parsh is going to walk us through how the app works here.
So this is the general front end of our app. Essentially the way it works is that I'm in this random location in Washington, D.C., and I've just illegally parked somewhere. I'm going to enter a latitude and longitude of where I am. For example, I'm at the Supreme Court. I'm going to enter distances, like latitude and longitude destinations of where I'm standing. And in this case, it's the Supreme Court. And I'm going to use BFS to find all the nearby parking violations. And then we're going to hit predict, and then we're going to see a results page, which is basically going to give us a summary of how likely it is that I'll get caught and get a ticket. So first thing I'll say is the execution time is very, very low because we're using the same exact graph and we're constantly updating that graph. And the violations found by the algorithm are 52. And what that basically means is that there's 52 nearby violations near where I'm standing or where I've parked. So there's 52 other people that have illegally parked. The total fines would be 3,320. And my probability of getting a ticket is 52%. And my probability of getting a ticket and all the violations are within that red circle. So that red circle you see is all the nearby violations of all the nearby like parking violations that have taken place. So now if we go back to a search, and then if I put like different latitude and longitude coordinates, let's say I put my favorite Indian restaurant. So latitude, it has a latitude of that and a longitude of that. And this time we use Dijkstra's instead of BFS. And then we hit predict. We're going to see the exact same thing, which is the execution time is low because, again, we're using that same graph. So it gets saved every time. The violations found by this algorithm are 48, which basically means there's just 48 nearby like parking violations near where I'm like based off of where I am. And then the total fines will be $3,420. And my probability of getting a ticket is 48%. And again, all the violations are occurring within that red circle. And if you hover over the blue like pin, you see all the information about my violation. And that's pretty much how the front end of our app works. And that's all. That's basically our project.
Hope you enjoy.